Hi friends, welcome back to your channel. In this channel we try to solve the previous year's physics question papers of Neet undergraduate exam. This is also helpful for those who are appearing for JEE Mains exam. This is solved in a very student friendly manner so that you can understand and apply the concepts. We have included all types of questions appearing in the exams so that your preparation is complete. If you like the content, we will request you to like the videos and subscribe to the channel. This motivates us to create more content for you and help you in your exam preparation. So without much ado, let's get started. So friends, in the previous videos, we had shared around 14 problems in electrostatics and capacitance. In one of the prior videos, we have solved the first 8 problems. Now we'll be solving the last 6 problems, that is from question number 9 to question number 14. So this is question number 9. So in this question it is given that the mean free path is 6 into 10 to the power minus 8 meters, right? So mean free path equal to 6 into 10 to the power minus 8 meters. Okay, now what is EV actually? So EV is electron volt. Okay, so when the voltage is 1 volt, right, the potential difference is 1 volt. When the potential difference between two points is equal to 1 volt. Okay, so imagine that these are two other points here. Okay, and the PD is equal to 1 volt, then the energy required to take an electron from point A to point B, okay, that will be 1 eV. Okay, so in this case it is given that the energy required is the electric field which has been given. So the energy required is 3 eV is the energy required. But this is required for 1 electron. Okay, so it means for normally for 1 electron for 1 volt, this is equal to 1 eV. Okay, so then it means if it is 3 eV, then it means that for 1 electron for 3 V, right? So potential difference is equal to 3 volt. It is given here. Now we know that E is equal to V by R. Okay, so the V is 3 volt and the distance is given to be 6 into 10 to the power minus 8. So this is equal to half into 10 to the power 8, right, which is equal to 5 into 10 to the power 7 volt per meter. So if you look at the options given to us, the C option will be the right option. Okay, so now we'll move to the next problem. In this question it is given that the energy, the bullet energy, bullet mass. So bullet mass is given to me. Bullet mass is equal to 4 grams, right, which is equal to 4 by 1000 kg. Okay, it is having a charge of 4 microcoulomb. What is the charge here? Is equal to Q is equal to 4 microcoulomb is 4 into 10 to the power minus 6 coulomb. Okay, yeah, so charge is given to be 4 into 10 to the power minus 6 coulomb. So so we all know that what is energy. In the previous problem we saw that energy is basically is equal to charge or Q into the voltage, right? We saw this is energy, and also energy is equal to half mv square, right? This is also the energy, right? So energy can be transformed from one to another, right? The different kinds of energy. So in this case, the energy which is acquired by the bullet due to the potential energy, right, it results in the kinetic energy of the bullet. Okay, now because of the potential difference, what is happening is that the bullet will move forward with a velocity, right? So this is what is happening here. So now let's put this, let's put the values in this. So uh, so it is given that q, we know q is the charge is given to us is 4 into 10 to the power minus 6, okay, into v we need to find is equal to half into mass is given to me, which is 4 by 1000, into velocity is given to me 20 square right here, okay. So it means this is 2, so I can write it that this is 2 by 1000 into 400, okay, means v is equal to 2 by 1000 into 400. 4 will come at the bottom here, 4 into 10 to the power 6, okay. So 4 gets cut here, okay, and 2, this is 5, so this is 1 by 5 into 10 to the power 6, which is equal to 2 into 10 to the power 5, 10 to the 5, this is equal to 200 kilovolt, okay. So this is the answer. If you look at the options given to us, the option 2 will be the answer, okay. Now let's move to the next problem now, right? The electric potential at a point in free space to a charge q is equal to, so q is given to me, so q is given to me as the electric potential is given to me as v is equal to q into 10 to the power 12 volt, okay. This 10 to the 12 volts is given to me, right? So we know that v is equal to q by 4 pi epsilon 0 into r. We know this formula, right? So r is equal to q by 4 pi epsilon 0 into v, okay. So if that is the case, now we know that we saw in the previous problem just now, right? E is equal to v by r, okay. So v by now v by r, so r is what, q into 4 pi epsilon 0 into v. So this becomes equal to v square into 4 pi epsilon 0 upon q. It's given to us that v is equal to 10 to the power q into 10 to the power 12, right? So it is q square into 10 to the power 12 whole square, which becomes 24, right? Into, now what is 4 pi epsilon 0? This will be 9 into 10 to the power 9, okay. And obviously this q is here, so it comes here, okay. This goes here like this, 10 to the power 9, this becomes 15. So this is equal to 1 by 9 into q into 10 to the power 15. This is the answer. If we look at the answers shared with us, if you look at the answers shared with us, the answer is A, right? Let's go to the next problem now. In this question, it is given that there are three charges residing at three corners of an isosceles triangle. So there is one charge is here, okay, the other charge is here, The third charge is here. Okay, so there are three charges here which are residing at three corners of the isosceles triangle, and it is given that the length of the sides CD and D B. So it's the isosceles triangle, so it means the two sides of our triangle will be of the same length, right? F and G are the midpoint. So F, this is the midpoint. This is the midpoint of this side, and this G is the midpoint of this side. So we need to know what will be the work done in taking a charge from F to G. So basically, we are going to take a charge from this to this, right? So this could be in any path. It could be from here to here. It could be like this also. It could be like this also. Like take it like this. Okay. We need to know that what will be the work done in taking a charge from F to G. Now we have seen earlier that what matters is the final state or the final position and the initial position. Okay. So now let's see whether there is a potential difference if this particle or if this charge moves from F to G. We need to just figure out that, right? If there is any difference, then only there will be some work involved. Otherwise, there is no work involved. Okay. So now when it is at F, right? So this is F here. This is F. When it is at F, okay. So the potential at F is equal to, because it's 2q here and 2q here, the distance is the same on either side, right? So because of that, this potential will be the same, which is 2q into k by b by 2 because this is b by 2 this side and this is b by 2 this side, okay, into 2 because of two charges, one at C and other at D. And the third potential is because of this, right? So imagine that it has some length. Okay, imagine it has some length. Okay, say imagine that this length is small a. Okay, so plus 2q into 2q is because of this into k by a. Okay. Now what is the potential? Similarly, what is the potential at G, for example? This is G, right? G. Similarly here also, this is B, so this is B by 2 and this is B by 2, right? So this is the same thing again, once again, 2q into k by B by 2 because of the charges C and E, the B by 2 into 2 plus, if this is A, the isosceles triangle, so this will also be A, right? This will also be A plus 2q into k by A. Now, if you compare the potential at F and the potential at G, right? If you see, they are the same. Okay, the magnitude of the potential at F is same as the potential at G, right? So in that case, the potential at F is equal to potential at G. So it means there is no potential difference. It means there is no work done. Okay, so the answer would be 0. If you look at the options given to us, so this is the option. C is the option here. Okay, now we go to the next problem now. In this question, it is given that an electric dipole of moment P is placed in an electric fluid of intensity E. So let me draw this here so that becomes clear how it is structured here. So imagine that this is an electric field here. Okay, this is electric field of intensity E. Okay, the intensity is the electric field here. So, and this is a dipole here. So these are two charges, right? As you know, in a dipole there are two charges. of equal magnitude but negative in neutrality. So minus q is here, plus q is here, and the distance between these two charges 2a. So imagine that this is center of the dipole marked in yellow color, and so this is a, this is a, and when it is placed in electric field, so on the positive charge plus q, the force will be in this direction, right, on the plus this direction, and in this case on the negative charge it will be in the opposite direction. Okay, and so because of this there will be a torque, right, and that is what we are trying to discuss here, that how the torque will be formed here. So because of this force here and this force here, so there will be torque, and which will try to rotate this dipole in this direction. That is what that is what this torque will try to do. Okay, we need to find the magnitude of this torque. So how to find the magnitude of this torque? So imagine that we have so it is given that the dipole moment is equal to P. Make it a little darker. Dipole moment is P, and electric field is equal to E. Okay, so what will be the torque here? Torque is equal to P into E. Okay, so in this case, if you look at what is torque for the positive q, right, positive q charge, what is the torque here? This is the force, which is F here, and from this, what is the distance, vertical distance between this is a sine theta into F, right? So this will be a sine theta into F. Okay, similarly for torque for negative q is equal to again a sine theta. Again, a sine theta is this distance from the center, vertical distance into F. Okay, so the total torque is equal to, just add these two, right? So it will be 2a sine theta into F. Now what is F? F is equal to Q into E, right? So this is equal to 2a sine theta into QE, because this is what F is equal to, right? So if we can just bring the Q here, this is equal to QA sine theta into E. So this becomes equal to PE sine theta. Okay, so this is the torque. Okay, so if you look at the given options, there are three of them, there are A, B and C, which have P sine theta, which is the torque here. Okay, now let's look at the second thing, which is the potential energy. Now what is the potential energy here? So in this case, so we know that the torque is acting in this direction, right, we stated earlier. Now to bring in the potential energy here, imagine that this is moved in the opposite direction. We do some work in the opposite direction here, so that there's some energy being stored in this, right? So what will be the work in that case? The work will be given as torque. So in linear motion, what is work actually? Work is equal to force into distance, right? In linear motion, we all of us know that, right? So what will happen in this case? In this case, it will be tau into the theta, which is moving here, correct? Imagine if this torque, if you apply external torque, and if it moves the angle theta here, okay, so that will be the work done, right? So it will be torque into d theta. Okay, so what is torque then? Torque is P sine theta, we know that. PE is sine theta into d theta. So if you need to calculate what is the total torque if it moves a certain angle, right? So it will be an integration of the entire effort, right? So dW, so this is dW, right? This dW. So work is equal to, in that case, work is equal to integration of dW. This is equal to dW is P sine theta PE sine theta into d theta. Okay, and imagine it moves from theta 1 to theta 2, right? Two angles. So this is equal to this is, I can write it like the PE, I can take it outside. Okay, this is theta 1, theta 2, and this is sine theta d theta. So what will be this now? What is the integral of sine theta? It will be minus cos theta. So this will become minus PE cos theta. Okay, wherein theta ranges from theta 1 to theta 2. Okay, so this will become, so this is minus PE cos theta, wherein theta ranges from minus theta 1 to theta 2. Now it is given that initially it was 0, right? Initially it was 0, so it means this will be theta 1. Initially the potential energy of this dipole was initially 0. If you look at the question, the last line which is mentioned here, right? Initially the dipole, the potential energy of the dipole was 0. So it means then per is equal to yeah, so the work is equal to minus PE cos theta. Okay, now this, as you know, that this work will be actually stored in this object, in this dipole as a potential energy. Okay, so the answer will be minus PE cos theta. So the torque was P cos sine theta, and the energy, which is the energy, okay, this is minus P cos theta. So if you look at the answer, the first one, A, will be the answer option. First option will be the answer here. Okay. So now we move to the next problem now. In this problem, so let's move to the next problem then. Okay, it is given that from a point A, there is a fixed charge, fixed point A. At A, electric field is 500 E is equal to 500 volt per meter. Okay, and the V is equal to 3000 P. So it is very simple here, right? What is the distance between the point charge and A? So we know that E is equal to, we know that E equal to V by the distance. Okay, so D equal to V by E. This formula, all of us know this. So this is equal to 3000 divided by 500. This is equal to 6 meters. If you look at the options given to us, the option will be option A. So friends, with this we have completed all the questions given for this chapter. Okay, I hope you are learning something from the videos. If you're learning something, we'll request you to subscribe to the channel and like the videos so that we get more motivated to prepare such content. Okay, so we'll meet you in the next video. Thank you.